What's up, guys? My name is Ritvik Rustagi, and today I'm going to be teaching you everything that you need to know about AP Physics 1 Unit 4 Energy. And before I begin, please go to the description right now and get my free AP Physics 1 book, because that book has everything that you need to know to get a 5 and an A in your class. So now, let's begin. So let's do some basics. Systems and forces. So a system is a group of objects that we specifically look at in a problem, and then an internal force is a force that occurs between objects part of that system, while an external force is a force caused by something not part of that system. So work and power. So work is the transfer of energy that is caused by an external force that is applied to an object. And then the formula is force times displacement times the cosine of theta, where theta is the angle between force and displacement vectors. And then only the component of force that is parallel to the displacement vector can do work. So that means if the force vector is perpendicular to the displacement vector, then no work is done by that force. And remember that power is the rate at which work is done. And to find the average power, you simply divide time from the work done to get what is the area under a force displacement graph? Well, the answer is the amount of work done. Now, how much work is done on an object undergoing uniform circular motion? Well, no work is done, and the reason is that the force and the displacement vectors, they are perpendicular to each other. Because think about it, right? The velocity is always perpendicular to the force, right? Which is why there is no work that is done. Now, there's three main forms of energy. The first one is kinetic energy. It's 1/2 mv squared. That's the formula for it, and it's the energy of motion. And then there's potential energy, and there's two types: gravitational potential energy and spring potential energy. So gravitational potential energy is the energy that is caused by the location of something, such as you in a gravitational field. The formula for the potential energy is mgh. And then remember that in general, something that's more important than gravitational potential energy is the change in the gravitational potential energy. And the reason is that the potential energy can be anything based on what you define your reference level to be, but the change in the potential energy will remain constant. And that's the reason why how much the potential energy changes is what matters more in these problems. Now, spring potential energy is due to an elastic object, such as a spring, being compressed or stretched, and the formula is 1/2 kx squared. Now, work energy theorem says that the net work done is simply the change in the kinetic energy. And if you want to see a proof of this, check out my book. It's linked in the description below. Now, mechanical energy. Now, whenever you're asked to find the mechanical energy, then you only add kinetic and potential energies. And remember that the potential energy includes both gravitational and spring. And then mechanical energy is also known as the energy that can do work. Now, if no work is done by external forces, then energy will be conserved. And this means that the initial kinetic energy plus initial potential energy equals to final kinetic energy plus final potential energy. However, if you have an external force, then that's what will cause the change in the energy. And that's why you can say initial kinetic energy plus initial potential energy plus the work done by the external force equals to final kinetic energy plus final potential energy. Now, conservative and non-conservative forces. So conservative force is basically a force, right, that does work when the path of the object is negligible. However, for a non-conservative force, the path of the object matters. The work done depends on the path for a non-conservative force. And then examples of conservative forces include gravitational and spring, while non-conservative forces include friction, tension, and air resistance. And the most popular non-conservative force in AP Physics 1 is friction force. Now, another way to write power. So we know that power is the work done divided by time. And then we also know that the work is force times displacement times cosine theta. So we have displacement in the numerator and time in the denominator. We can divide both to get FV cosine theta. Now let's look at an actual free response question from the actual AP exam. So please pause the video and try the problem on your own. So basically in this problem, right, there's a 10 kilogram block that is pushed along a rough horizontal surface by a constant horizontal force F as shown above. And then at time t equals to 0, right, the velocity v of the block is 6 meters per second in the same direction as the force. And then we're given that the coefficient of the sliding friction is 0.2. And we can assume that g is 10 in this problem. So in part A, we want to find the force necessary to keep the velocity constant. Well, constant velocity means that the acceleration is 0, and 0 acceleration means that the net force is 0. So we know that there is one force that's applied, and then there's a friction force. And that means F minus F of F equals to 0. So that force is friction force, which is mu n. And we can find that N, the normal force, is mg. So we get F equals to mu mg, which is 0.2 times 10 times 10. And we get 20 newtons for the force. Now in part B, right? Basically first, the force is now changed to a larger constant value F prime. And now the block accelerates so that its kinetic energy increases by 60 joules while it slides a distance 4 meters. So this means that the change in kinetic energy is 60. So we use the formula, the net work done equals to change in kinetic energy. So the net work done is F prime times displacement. So the work done by this applied force, right, of F prime minus the work done by friction, which opposes the work we do. So minus F of F times D, which is the distance. And this equals to 60, which is the change in the kinetic energy. So we can plug in 4 for D, and we know that the friction force, right, it's 20. So now we can divide both sides by 4 to get that the F prime is 35 newtons. Now in part C, we want to find the acceleration of the block. So we know that net force equals to mass times acceleration. So net force is force, right, F minus F of F, which is the friction force, and this equals to mass times acceleration. So our force that we apply is 35, friction force is 20, and then mass is 10. So we can solve for acceleration to get 1.5 meters per second squared. Now let's look at another free response question from the actual AP exam. So please pause the video and try the problem on your own before we proceed. So by now I hope that you actually paused the video to try the problem. So let's look at the solution. So there's a 2 kilogram block that is released from rest at the top of a curved incline in the shape of a quarter circle of radius r. And then after it comes down, right, the block then slides onto a horizontal part, right, where it comes to rest 8 meters from the beginning of the plane. And then the curved incline is frictionless, but there is an 8 Newton force of friction on the block while it slides horizontally. And part A, we want to find the magnitude of acceleration when it's sliding along the horizontal part. So let's use the formula net force equals to mass times acceleration. So when it's on the horizontal part, the only force, right, horizontally will be the friction force, and this equals to mass times acceleration. And we're given that the friction force is minus 8 newtons, and this equals to 2, right, times acceleration, because the mass is 2. We can divide both sides by 2 to get that acceleration is minus 4 meters per second squared. Now in part B, we want to find how much time elapses when the block is sliding horizontally. Well, we know that for the horizontal part, right, there will be an initial velocity and the final velocity. We don't know the initial velocity of the block, right when it enters the horizontal part, but we know the final velocity. It's 0 because it will come to rest. We know the acceleration, -4, and then we know that the displacement in the x direction, right, for the horizontal part is 8 meters. So we can plug this into this equation, and then we can simplify to find that initial velocity squared is 64, which means initial velocity is 8. Now we use the equation final velocity equals initial velocity plus acceleration times time. Initial velocity is 8, final velocity is 0, acceleration -4. Now we plug everything in, and then we can simplify this to find that the time is 2 seconds. Now in part C, we want to find the radius of the incline in meters. Well, let's use the conservation of energy. So initially, right, when the block is released, it will be at rest, which means that there is no kinetic energy. However, there is potential energy. Now by the time the block finishes the curved part, the gravitational potential energy, right, it will convert to kinetic energy. And then the change in the gravitational potential energy is mgr, since it moves down a distance r, the radius, and this equals to 1/2 mv squared. We can divide both sides by m, and then we can simplify to get r, right, equals to v squared over 2g, and we plug in 8 for v and 9.8 for g, and we can find that the radius is 3.265 meters. Now thank you so much for watching this video, and please don't forget to like, share, and subscribe, since that's going to tell me that you guys are truly enjoying and learning from the books and the videos that I've been making for you guys. And don't forget to join the Discord server to meet other hardworking students that are preparing for various competitions and exams such as the AP exams. And also, don't forget to follow the Instagram if you have Instagram to view educational reels and cool animations. And again, thank you so much for watching this video, and I really hope to see you soon back again on this channel.